Hello friends, welcome to question number 5. We are calculating angle ADB. So in this triangle, we see that all the three sides are given. And so whenever we are trying to calculate an angle when all the three sides are given, what should we do? We would use which rule? Cosine rule, right? And so what can I say? Cos of angle ADB, this will be equal to the two adjacent sides ADB, this is the angle, and so the two adjacent sides BD square plus AD square minus the opposite side square by 2 into the adjacent sides BD into AD. And so if I substitute the values, then it would be 8.6 whole square plus 9.7 whole square minus 4.4 whole square divided by 2 into 8.6 into 9.7, and 8.6 whole square is 73.96 and 9.7 whole square is 94.09 and 4.4 whole square is 19.36 divided by 2 into 8.6 into 9.7. So this is equal to 166.84, and if I calculate the value, this will be turning out to be 148.69 divided by 166.84, and so cos angle ADB would be equal to 0.8792256, and if I apply its cosine, then for angle ADB would be equal to cos inverse of this value, and cos inverse of that value in degrees is equal to 26.97391 and so on. So because answers they are required to be given in three significant figures, you can stop it here. 26.97, this is the correct answer. Okay, so just remember, whenever you see a triangle with all the three sides given, that's it, you are going to use cosine rule. Now the second part, calculate DC. So we are calculating DC here. So look at the picture carefully. We know these two angles, so we also know this angle. This angle is nothing but 180 degrees minus 42 minus 65, right? And so we know the three angles and we know one side, so we can use the sine rule. So I can write, applying sine rule, and for the sine rule this would be, the sides I pick are DC and DB because I know the value of DB. And what are the opposite sides? For DC it is angle B, and for BC the opposite side is that angle C. So DC divided by sine DBC is equal to BD divided by sine BCD. Okay. Now angle BCD, so therefore DC divided by sine angle DBC, which is 65 degrees. So sine 65 is equal to BD, which is given to be 9.7 divided by sine of 180 minus 65 minus 42. So therefore DC would be equal to 9.7 into sine of 65 degrees divided by sine of, now this value is 180 minus 107, which is 73 degrees. And so if you calculate the value, DC would be equal to 9.1928702 and so on. So if I cut it to three significant figures, the correct answer is DC is equal to 9.19 centimeters. That is the answer, right? Again, it's a direct application of sine rule. These are straightforward questions. And C part. So calculate the shortest distance from C to B. Shortest distance. And in every case, what is the shortest distance? The shortest distance from a point to a line would be the perpendicular distance. right? So if this is E, then what can I say? CE is perpendicular to BD. So if CE is the shortest distance, then CE is perpendicular to BD. That is the required point. And so now in triangle CDE, what can I see? So in triangle CDE, this is a right angle triangle, and I know this side, I have calculated it. So I know the hypotenuse, and I want to find out, I know this angle 42 degrees, and I want to find out the opposite side. So which side? Hypotenuse and opposite, which one will you use? Sine. So sine of angle uh, CDE would be equal to the opposite side, which is CE, by the hypotenuse, which is CD. So therefore, CE would be equal to CD into sine of angle CDE, which is nothing but CD. I already got it as 9.19. We already got the value as 9.19 into, or 9.19280.702 and so on, into sine of angle CD, which is sine 42 degrees. Now, if I calculate the value using calculator, I will get 6.15123083 and so on. So this is the value of CE that I get. Again, if I cut it to 3 exact parts, the answer would be 6.15 centimeters. This is the value. So always remember, shortest distance between a point and a line is the perpendicular distance. Very, very important point. Okay. Thank you.